Thank you. Hello, everyone. Today I'm going to talk about generating production code, which is something that can be a bit unusual in a code base, but here it was the best solution that we found for our problem. So I'm a senior data engineer at Content Square, and part of that role is to maintain the technical stack. Through that, I work on a project called ClickHouse Forest, which will be the basis of this talk. So what is ClickHouse Forest? We have some Scala services on one side, obviously, and on the other side, we have a database called ClickHouse, which is not just SQL. It goes a bit above that. So we couldn't choose as a driver things like Slick, and there was not really something at the time for ClickHouse. So we decided to build our own, and the big decision that we took very early on was to say, we want the queries in our Scala code to look as much as possible to what you could do when you contact the database directly. And this is drive us to our problem that we will talk about today, generating the code. So with the database, I would say, as usual, you can have aggregated functions like sum, but the particularities here is you can add something called combinators, like the if. And if you add the if, it will add a predicate as a second argument. But you can also use multiple combinators at a time, and their order is important. And there are also weird combinators like array that you could theoretically use an infinite number of times. With that, so you have a dozen combinators, you have 69 methods. If you want to generate all of them or to write them all, it's going to be quite a tedious task, especially to maintain that over time. And so this is where we thought, well, we might have to write thousands, thousands, and we thought, okay, maybe here we need to generate those. So our objective, what we want to have at the end, is to write something like that, where you have some Scala documentation, you have an add since, which says since which version of the database the method is actually available. So you retrieve the name of the function of the database, all its arguments, and well, usual Scala code. For that, when you look online for how to generate code, they don't give you the full picture. What they are talking to you is about templating, which when you already know your input, for example, if you want to build 10 routes, 10 HTTP routes, well, you can have a static file, static thing, and then use a template to generate those. In our case, we didn't have this static input. It was dynamic, so we had a bit more to do. But first, on templates, you have three kinds of templates: string interpolation, using a DSL, or Scala macros. For the string interpolation, if we look at this example from the Play framework, you can see that you have imports on the top, you have a package, which contains objects, variables, methods. So the great thing about it is you can read the template and you actually know what the code is going to look like. It's also very flexible, but because of that, also, you could make a typo, and you are not going to know that you made a typo before you actually generate the code. So the feedback loop is not that great. And also, in our cases, it means that we are going to generate files that are super huge. And even if you deactivate, for example, the formatting in Scala FMT, Scala FMT still spends quite a lot of time on the file. The second alternative is to use a DSL for that. And if I take the last example on the right, if you want to write case class var with an input that extends expr, well, you say, I want a case class. This is a name. It has a parameter name, which is a string, and its parent, so it extends expr. This time, the main difference is your code is going to compile its verified through this DSL, and that's very great. But still, we are going to generate the code in the end. And for Scala FMT and Scala Fix, it's going to be a bit of a pain. And there is an in-between, actually, that improves the last point. So you could use also Scala macros and the quasi-quotes operator. So the quasi-quotes operator lets you write some Scala code in a string, and there is already some kind of verification of what you just wrote. So you cannot ask an abstract trait. It will say, no, if you have abstract, I'm expecting something else than that, like class. So it's not going to fix all the typos that you could make, but it helps a lot. And the big point about it is you don't need to first generate the code and then compile your project. It's the compiler that is actually going to do the task. So your project is not going to contain all this boilerplate, all this code that is just huge for not much value. The problem with it is that it's experimental in Scala 2. And because of the internals between Scala 2 and 3 changed a lot, in a library like ours, where we want to cross-compile between Scala 2 and 3, we cannot use that. So 3 ways about templating, 3 ways to go. So at first, I said that this our inputs are dynamic, not static. So for that, what we did is to build a run method. It will read its own file, actually. And when it faces the commands aggregating functions on and off, it's going to know that it must replace the code in between. And what will it be replaced with? With was the response of the generated code. So here we would say, I have a meta method like sum, count, and all the other aggregated functions that we support. We are going to define what combinators do. If I have an if, it means that I need to update the name of the function and add a second argument. So I'm basically generating all the combination of combinators that I want to support with the methods, and then we can use our templates. So for this, we have few templates. This is one of those, and that will explain why we went with string interpolation. So you can see that we are creating a method. We have some parameters, we have the generic types, we have the Scala docs. But because of the number of variables that we use in our templates, it felt much easier to maintain if we could read the code, which is why we went with string interpolation. If we went with the DSL, this method would have been very huge and quite hard to understand what's actually going on. So the key takeaways for us about this first part was to say, when we generate the code, it's fully deterministic. It's not like the order of the functions we generate are going to change or anything. Removing this randomness helps people also trust what you are doing because it's unusual. Also, because it's unusual, we decided to heavily document that so that someone who is not aware of this code can come up, see some Scala doc and say, okay, this is some weird code that I'm not used to, and I can understand it. And it was super useful for people who wanted to add new methods to support. And the last thing is my personal point of view on this is to restrain this kind of code to a specific part of your repository. So in our case, it was a file, but it could have been a package. It's important so that people can say, in this part of the code, I'm very comfortable. It's what I'm used to when I see some Scala code. But on this specific part, it changes a bit. So I need to be more careful. And with that, so we got some generated code. That's great. But then you need to prove to your teammates that it's actually going to work. So you need to test that code. And how do you do that in Scala? We decided on 4 principles to drive our testing strategy. The first one is to not trust how we generate the code. So it's not while we generate the code that we also want to generate the test. They should be completely separated. Also, we have to define what is the goal of the test. Here, our user expects that when they call a function called sum, it's actually going to write a string sum. And with the right arguments, that they also expect that the method exists in the database, etc. So for that, because it's not just unit test, we needed to run it in a control environment. So we use Docker to have the database, and that way we can query it using the generated code. And last, we know that there could be human, well, you can miss something when you create a PR to add a method, for example. So we wanted to make sure that we would have 100% testing on the generated code. We cannot allow ourselves to push some code that we're actually unsure about what it's going to do. So it's not the most important thing, I believe here. It's just on the next slide what I'm going to talk about reflection to actually call those methods. But for the general structure of what we did, in the companion object of our test, we decided to parse all the generated code and to build a data set of the functions that were created, their inputs, outputs, and etc. That way, when you say, I have the sum function, I can check, okay, everything that starts with sum, I take all of them and I test them all. So we did that, it worked well. And we added a last test, which is let's hardcode the number of expected number of functions to test. So it's not the most beautiful code that we could have written, for sure. But this is the way we say, if you add a function to in our generator, well, this method, this test is going to fail. So you need to update the number of tests. And if you do so, you are aware that this file exists and you need to add a test above. At least if you don't, it's going to be seen in the pull request. But how do we call actually the code that is generated? Some people could be about, let's do some TDD. So the code doesn't even exist. We don't even have the signature of the method. In that case, how do we do? So we decided, obviously, to go with reflection. It's like we don't see any alternative for that purpose. And at first, we went with scalar reflection. It felt quite simple. There are some examples online for basic usages. And what you do is you say, I'm going to use your internals to access reflection. And then you say, oh, I want to access things in the aggregated function companion object. The method here is the name, and you can use some alternatives. For example, the count method exists without parameter and with one parameter. So you have two methods with the same name, and you need to differentiate those. So it works very well in Scala because the methods that are retrieved are in order. So if I want to differentiate my two counts, because I have the full control on what is generated, I can say the one without parameter is always first. So one with one parameter is always second. So I just need to provide the index here. Also, at first, we didn't face this issue actually about having to choose alternatives. We thought that every method would be unique. And for that, we got very great error messages at runtime when we run our tests. And it quickly helped us to find what was the issue and how to solve it. So good job there. Because especially on this point, you don't see much question actually on Stack Overflow about this, because there is very few people that needs that. However, when we decided to migrate our library and to cross-compile it between 2 and 3, well, Scala 2 and Scala 3, we had to look at the migration guide of Scala. And they said, well, you have two choices, basically. The first one is you completely migrate your code to Scala 3. which is not an option for us. And unfortunately, there is only one fallback, which is to use Java reflection. So the good point is, because Scala is running on the JVM, you know that Java reflection is always going to work. But with Java reflection, you are going to have a file with both Scala and Java, so you will need to care about switching the types between one to another. And it's really weird to need to do that. Also, with Scala, with Java reflections, you lose the fact that methods are read in order. So you don't have any alternative index anymore. What we had to do is say, we first retrieve our dataset of methods, and then we need to find a predicate that identifies my method. And it's not necessarily that easy, because if you say, I have my count with no parameter, I have one with one parameter, yes, but when you add a combinator called if, it creates actually an additional parameter. So you really need to think through about what filter you want to use. And then, well, it's Java reflection. So you just say, hey, here is my, I retrieve my method, and then I put the arguments. So the rest works. But it was not really pleasant. And obviously, when you do that, the error messages are quite ugly and not really helpful. So if I had to recommend, use Scala reflection. It's super great. We got a nice developer experience. But unfortunately, for a library, we basically had not much of a choice. Well, we could have kind of duplicated our tests between 2 and 3 and have multiple packages to maintain, but we couldn't take that decision at the time. So thank you, everyone, for following this talk. If you have any questions, I'm ready to take some of them.